Hi, my name is Curtis Bowman. I am the board chairman for UALink, and today I'm going to tell you a little bit about what UALink is, or Ultra Accelerator Link, and hope that you'll enjoy our little presentation. To start out with a little bit about why we do it. So UALink was created because what we realized is the AI models are continuing to grow, and they require more and more compute and memory in what they're doing. And that's bigger than what you can get out of one accelerator or one GPU. And so the what we looked for was something that the industry could use. And the reason of that is really when you look at data centers, you need to have some commonality in the networking infrastructure, or it becomes very burdensome to have a rack for every vendor type of accelerator out there. By giving us a common link, that really allowed us to be able to provide the industry with something that was useful at the top or the middle of their rack. What we figured out was that, for large inference models, we were going to need tens to hundreds of GPUs. And for large training models, we need somewhere between hundreds and tens of thousands of those accelerators. So group got together, and here's the board of the consortium. And then what we said was, let's go create a spec that would allow us to meet the needs of the industry and the various accelerators, as well as find very great switch providers that could give us the types of latency we need when you're sharing memory. And so you can see strong group of Alibaba, AMD, Apple, Astera Labs, AWS, Cisco, Google, HPE, Intel, Meta, Microsoft, and Synopsys are grouping together to lead this consortium. And our main points are we need it to be high performance because you're sharing memory. It needs to be open so that multiple companies can participate, and it truly needs to be scalable. And you'll see that scale as we move on. If you look at the size of the organization, we're about 85 members now. Along with the board, you can see there's a number of contributing members, and we're growing every day. And so very pleased to see the kind of growth we had here since we started. And if you look at our calendar, we actually started this effort a little less than a year ago. In May, we formed the promoter group. By October, we were ready to release it as a consortium for other members to join. Then in January of 25, we were able to expand our board to include some more members. And we have released our first spec internally. Here we are in the middle of March, and we're driving toward the release of that spec to the industry the first week of April. So here's a little bit about what UALink is. It's really an accelerator to accelerator interconnect. So think of it as a backside network for those accelerators. And in the initial stages, what we're looking for is how do we share memory? And that can be DDR connected directly to the accelerator, or it can be HBM that's captured internally. The reason that we went with UALink is we needed something that was direct load store solution. So very memory-centric environment that allows for the communication of those memory packets across a link, or the memory flits, as compared to packets that would be on something like Ethernet. We also wanted it to scale to hundreds of accelerators. And what you'll see is we actually go to 1024 accelerators. One of the things that we looked at was, well, what's the signaling rate that we need? And that was a great discussion that we had, and we settled on two. One is using 128 gigabit per second PHY that is leveraged from what PCIe rates will be getting to in Gen 7, or the 200 gigabit per second PHY that is what's being used by the Ethernet world right now. We felt like both of those were important, and so we have the ability to support either PHY. And then, it taps into the experience of those promoters that you saw, or the board members, and what they need in their data centers, and allows us to deploy that across a wide range of different data centers. And in the picture, you kind of see the idea of how we share memory. You can share memory from a different accelerator, or the memory that might be in the host from that accelerator. So it really allows you to expand your memory quite significantly. We do see that UALink does create this scale-up ecosystem. So you can see on the picture on the right here that what we have is a number of accelerators. So a host can support anywhere from 1 to 8 accelerators, depending on the architecture. And then those accelerators connect to one layer of switch. So you get multiple switches attached to multiple accelerators, which gives you the high throughput that you need. And the switches are very low latency, so you get that low latency that's required when you're talking to memory. As you can see here, we optimize the performance for the compute needs of those workloads that are very memory intensive right now. Plus, it can scale into the future because we can see going from 200 gigabits per second bandwidth to the next generations, whether that's 400, 800, 1600 gigabits per second links. We also see that it scales up very nicely, with really important advantages, and I'll get to those a little bit more in another slide, but you get performance advantages, power advantages, cost advantages, and those are all important to us. As I mentioned, we were incorporated in October of 24, and this slide actually is slightly dated now because we're at 85 members, so we continue to grow since we released in October. Now let's talk about some of those advantages. So performance. So UALink is really a simple load store protocol. And it has that same base bandwidth as Ethernet, that 200 gigabit per second bandwidth. And it has a higher efficiency than Ethernet because we're not trying to packetize it. We're putting it into flits and we're sending it across the wire. Also, we're using switches that are much more similar to PCIe switches compared to Ethernet switches. So our pin-to-pin latency inside those switches is somewhere in the 100 nanosecond range. We also see that we can very easily add collectives into our network, which allows you to offload the accelerators for some of those simple tasks that need to be done. Big piece is power. So what we see is by using UALink, which is a very simple protocol, very effective in its use of the die area, we actually save somewhere between 75 and 200 watts per GPU or per accelerator when you compare that to an Ethernet solution. Part of that is in the interface, part of it's in the switch itself. But when you start to look at how power hungry accelerators are getting, being able to save 75 to 200 watts means you're able to add more power to your accelerators. The other thing you do is cost, right? So UALink is very efficient in its die area. It's a half to 1/3 the area of an Ethernet solution. So that reduces your total cost of ownership because you've got lower power, you've got lower acquisition costs. And then we have an end-to-end security. So you can be very comfortable that your data is safe both at rest as well as while it's in flight. And we feel like because it's an industry standard, we're getting that strong global support. If you looked at the members, you can see they're from all over the world, and they're showing us that this is something they need to be able to properly design and deploy the products. And then finally, supply chain becomes really important. What we want to do is allow for multiple vendors for the accelerators as well as multiple vendors for the switches. When you look at an Ethernet environment, great things are going on there, but latency is a challenge, right? To get to low latency Ethernet switches, you really get down to a very limited number of suppliers that you can use. And what we think is that we have vendors that are driving very aggressive schedules to be able to meet the needs of the accelerator vendors. And so we'll have the switches and the accelerators coming out in a very short time. It's something to keep your eye on. Now let's look at the UALink stack. I've told you it's very efficient, fairly simple. This stack is the 200 gig stack. What you see here is we reuse the layer 1 level right from IEEE 802.3.dj, 802.3 DJ. It is um, uh, the standard interface, right? The fives are out there in the world, the SerDes are ready to go. Where we get into uniqueness is up here as we get into our data link layer and our transaction layer. What you see is this is where we get very simple. We use a fixed payload that allows for very efficient movement of the data. We've got a nice low latency operation, so cable lengths of under 4 meters, supports 1 to 4 racks. And you can also see that we have end-to-end data confidentiality, as I mentioned on the previous slide. What this looks like in a data center is, here we're showing 3 racks connected by Ultra Accelerator link. And again, you've got your multiple hosts, but all your accelerators connect to all the switches. And what that allows for you to do then is have a single layer of switch, so you have the minimal latency between those accelerators. And you have this great bandwidth, but because you're going through multiple switches, you can increase that bandwidth between all of the devices that are connected. And what that means is that you don't see the bottlenecks that you might see if you're trying to cram too much stuff through a single switch. And then finally, what about joining the group? Well, if you join UALink, we have multiple work groups. In alphabetical order here, compliance is one group. That's always important because we want to make sure that if you buy something that says UALink on it, it will interoperate with everything else that you buy. We have the DLPL group, or the physical layer group, that's looking at items there. The protocol transaction layer group is looking at stuff that's just up the stack from that. Then the security work group is the work group that really is dedicated to making sure your data stays secure. In a single environment or a multi-tenant environment, you're going to have safe data. And then, of course, you want to be able to manage it all. So we have the systems and manageability work group. And then finally, when we talk out to the world, we need a marketing work group to help us do that. And so there's a marketing work group. So regardless of what you're interested in doing, we've got a place that you can help UALink spread the word and improve their spec over time. And just to close it up, we think UALink is important because it creates this open ecosystem for scale up. It primarily targets, that efficient, low latency, high bandwidth network that goes across a few racks or up to 1,000 accelerators. And then with the launch in October of 2024, we will have our initial specification ready in April of 2025. And I encourage you to visit our website, our LinkedIn site, see our communications out on X as ways to continue to stay up to date with what we're doing. With that, I thank you for your time and hope you learned a little bit more about UALink. Visit our website if you'd like to know more.